So in the chemical analysis, we first get to know about the chromatography. Chromatography will be having what? Chromatography will be having two phases. One is called as a mobile phase and one is called as a stationary phase, right? Isn't it? The mobile phase will be the solvent which you are using. The paper which you are using, the chromatography paper, is the stationary phase, right? Stationary phase, right? We are having, right? Guys who will be studying A levels, this chromatography will be going over to a further deeper levels, right? You'll be learning TLC, you'll be studying gas chromatography. Those will be studying IBDP. They will be restricted to this part only, right? Isn't it? That's all, right? But A levels goes deeper, right? So in the chromatography, we have got paper chromatography in a syllabus, right? In the paper chromatography, we have taken a paper chromatograph, right, over here, and this is a stationary phase. And we have taken the solvent, right? We put the mixtures to be separated out in this pencil line we have drawn, and putting the solvent. The solvent is the mobile phase, right? Now you have to remember one thing: the solute which you're taking, right, the solute which you are separating out, these are the solute which are separating out, will be having an attraction with the stationary phase, with the paper, as well as with the mobile phase, right? If it is having more attraction, forces of attraction with the stationary phase than the mobile phase, right? Again, I'm telling you, if you're having, if you're having the solute having more attraction with the stationary phase than the mobile phase, right? Isn't it? Then you'll be seeing that the solute will not go faster, right? Now, oppositely, if the solute will be having more attraction with the mobile phase than the stationary phase, right? My question to you is that in that Zoom chat, if the solute is having more attraction with the mobile phase than the stationary phase, will it travel faster or slower? Right? F or S quickly. If it is having attraction with the mobile phase than the stationary phase, will the solute travel faster or slower? F or S, right? Who's the fastest finger? Hitakshi is the fastest finger, right? Wonderful. Kritik is the next fastest finger. Nithila is the next, right? Wonderful. Wonderful. Hanshika is the next. Jackie, wonderful. Jackie. Mokshi, where are you, right? Please participate, right? Everybody participate. Kailash, where are you? Please participate, please. Thank you. Send me a direct message, right? Okay, Kailash has sent. Sorry. Kailash, send me a direct message, right? Thank you so much. You will be seeing that while you select the message, there will be option that send to everybody or send to me, right? Anyways,
For
thank
me,
you
I
so
don't
much.
have that feature. It just
Oh,
says
you
message
don't have the
everyone.
feature. Okay, everybody's sending like that. Anyways,
It
so
just
that.
says message everyone on my thing.
Oh, are you joining from that app or from the React browser?
I'm on the app.
Okay, fine. But sadly, it is not current. Anyways, to get my point, right? This bit is clear. Please open your book and mark it to the bar infinity over here, right? Now, my question, my prediction is that if you change the chromatography paper, right, the RF value changes. What's RF value? RF value will be nothing but its distance moved by the solute x divided by distance moved by the solvent, right? It's a ratio. So if you change the chromatography paper or if you change the solvent, right? If you change the solvent, right, you'll be seeing that. Yeah. Now Ishani has a suggestion to Kailash. Kailash, she's saying that if you click on the blue button on the top left to the message, only 1%, right? You can go to that. What she's suggesting. See, this is the beauty of the group session, right? Fine. Thank you.
Okay.
Thank you so much. She's saying that if there's a blue button there on the wait, let me read
Yeah,
that
yeah, I
message.
have that.
The blue. Yeah, thank you so much. See, thank you so much, Ishani, for helping. Right. Thank you so much. Did you get my point over here, right? So there's a RF value. RF value will be typically telling you that what amino acid is there, right? What exactly? Because RF value will be constant, right, for a particular substance. Now my next prediction is the uh, yeah, this carbon dioxide test will be definitely there. My next prediction is this, right? Just a suggestion to you, everybody. If you're having a 3 marker to 6 marker question, everybody, I'm telling you, whether or not you're having a good artistic hand, forget about. Make sure that you draw drawings. Please type out this, Kailash, for 3 to 6 marker question. Back up with drawings, right? So you know that lime water milky we are having, right? Now next prediction, my this flame test, right? There'll be a question that why do we why do we use hydrochloric acid, right? Why do you use hydrochloric acid? We use hydrochloric acid to clean the nichrome wire, right? Isn't it? Please open your book. is a is the element which we test, right? There are not all elements which give you the flame color. What we do, we take the nichrome wire, we dip it in concentrated hydrochloric acid, and we bring it to the flame. Dip it, bring it to the flame. Till the time there is no yellowish flame over here, right? Isn't it? We burn the impurities to remove the impurities, right? Next, we dip it into the solution or the solid salt. If it is lithium, it will be crimson. If it is sodium, it is yellow. If it is potassium, it will be lilac. If it is calcium, it will be orange red. If it is copper, it will be greenish, right? Isn't it? So these bit you have to master, right? Isn't it? Now, next bit. My prediction is this. Open your book, 187, right? Please mark it e to the power infinity. My prediction. Fine. Thank you so much. Do you get my point? Just make sure that you're going around this, right? Isn't it? Now, if you see when we talk about when we talk about, right? Just give me 1 minute. Okay. Now see, now if you see when we talk about when you talk about the testing, right, of the positive ions, the flame test gives us a much more amount of a smaller amount of conformity test. See, very less amount of conformity test, right? Isn't it? But if you see that the process by which we get a larger amount is the wet test. We take what? We take the unknown solution and we add sodium hydroxide, right? In it. Either one of them will be there in a exam paper, this, right? Just remember this thing part that we take sodium hydroxide, we dissolve the unknown solution. If we are having a white precipitate, it will be aluminum, magnesium, calcium. It's colorless precipitate. What you do, if it is colored, if it is light blue in color, it will be copper 2 plus. If it is reddish brown precipitate colored, it will be Fe plus 3. If it is light green in color, it will be Fe plus 2. So colored is quite simple. We can get the colored one, right? Quite easily. But if you have got a white precipitate, right? Either it will be aluminum, it will be magnesium or calcium. How to differentiate between them? To that precipitate, we add excess amount of sodium hydroxide, right? When we add excess amount of sodium hydroxide, what we do? If the precipitate dissolves, we call it Al plus 3 is confirmed, right? If the precipitate is insoluble in excess sodium hydroxide, we tell that it is either magnesium 2 plus or calcium 2 plus, right? Isn't it? My question to you is this. Now we have reached till over here that the precipitate was not dissolving, right? Insoluble. Now, can you tell me, guys, that how can you differentiate between these two? Either it is magnesium or calcium. How to distinguish between? Finally, we got an idea that from the
I
all the positive ions, we are having either magnesium 2 plus or calcium 2 plus, right? Because you are having a white precipitate and the precipitate did not dissolve in excess sodium hydroxide, that is calcium or magnesium. How to differentiate between calcium and magnesium, right?
flame test.
There's a way, Kailash. I understand. Fine. Thank you so much. Thank you so much. Kritik is the fastest finger, right? Kritik is the fastest. Nithila is the next fastest finger. What about others? Use a flame test, but be specific as Kritik does, right? So I need clinical warfare to be happening, right? Clinical. You have to be clinical. You have to be hit the target perfectly, right? Yes. Flame test, right? So Kritik was much more clinical, right? Indeed. Um, Nithila was clinical in some answer. Mokshi was clinical. Ishani was clinical. So I'm Jackie, not to right, not to forget, right? Wonderful. Ishani, Hanshika, Hitakshi, amazing. Mohit, right? Wonderful. Everybody, right? Everybody. Thank you so much. Wonderfully doing, right? Kailash, right? Everybody, wonderful. I'm proud of you. Yes. So calcium is will be orangish red or brick red also, but the magnesium does not have any color, right? Kritik was clinical, right? Thank you so much over here. Now we are going to the next part. We're going to the next part of what? We're going to the next part of that. You go through this bit, right? Open the book, right? Quickly. Page number 190. Instrumentation process, right? We're seeing the instrumentation process, right? What's the instrumentation? What are the advantages? The advantages of the instrumentation method is that only a very small amount of sample can be analyzed. This should be coming first, this, right? Next come this, it's highly accurate and sensitive. And it's very quicker, right? It's very quicker. Within seconds, it will be getting, right? What are the disadvantages of it? The main disadvantage of these machines is that you need proper training. This comes first. This comes first, right? You have to take specialized training. Second, why the schools cannot have these? Because it's very expensive, right? Very expensive, right? My suggestion to everybody who will bring IBDP, right? You have to do a PhD work, right? That's called the IA, right? You might have done your MYP, right, in IS. So always in your school, you will be having spectrophotometer, right? Whenever you're doing an IA, always try to take the spectrophotometer and do that. That will be much more better. Because see, it's a instrumentation method you're doing that experiment, right? Thank you so much. So it is expensive, right? Finally, you can only interpret the result by comparison from the unknown data, right? Sorry, it's known data you have to fit, right? Isn't it? How do the flame spectroscopy is? So this is also a important portion, right? Please take open your book and mark this 193. Kailash, please type out 193, question number 4. This will be there. Hmm. See, it's very simple. We have got the mixture over here, and we have got the flame spectroscopy of lithium, sodium, potassium, rubidium, calcium, arsenic, right? We have to match it, right? Isn't it? We have to match the flame spectroscopy, right? So does it contain lithium? This does not contain lithium, right? This is not actually reflected over here. Does it contain sodium? Right? Let's check. If you're seeing that sodium, let's check potassium. Potassium is there, right? Potassium will be there. Now, guys, can you tell me that what are the elements which you see over here, please? Please do this question. What are the elements which you see, right? This is a mixture of the elements you're having, right? This is a mixture of the elements, and this is the lithium, sodium. But you have to match it, right? Please send me, please, huh? Okay. What are the elements if you see? Thank you. Fine. Thank you so much. Anybody can tell me? Was the elements? Kritik is the fastest finger, right? Thank you so much, guys. Thank you. Yes. Everybody, fine. Thank you so much. Very good. Very good. Hanshika is the next fastest finger, right? Jackie, Mokshi, please see. Uh, so Kritik has written what? Kritik has written over here potassium and sodium. Perfect, right? See, sodium we are having this, right? We are having this. And potassium also we are having exactly same, right? We are all is matching, right? All should match, right? So entire thing will be matching, right? Isn't it? So calcium does not match, arsenic does not match, right? So this was all about what? This was all about the analysis portions we had, right?